E over n, you have this term E square over n multiplied with the field E. So now things becomes exactly the same as the paper here, but not yet, because he take the time derivative, so we need to take the time derivative. So we have this P here, we just take the complex part. Okay. We ignore the half because every term here carry the half. So the half, there is a half here also, but also considered already. So we can simply substitute all the P with this P. Okay. So if you take the time derivative of this P, so you have the P function of Z. This time factor, you take the time derivative of this time factor, you have minus omega squared. This term, you have the minus I omega, because you take the first order time derivative of this. You get the minus omega squared because you take the double time derivative. If you take only one time derivative of this, you have only minus I omega. All right, so this term is come from this. And then this term will give you here. Okay, and this term will give you here. And this term remain the same. All right, then after this, you can see that every term carry this this exponent, this exponent. You can cancel all the exponent, so you left only this. And for the left hand side of the equation, every term carry pz. So after this, you factor out all the pz. So inside the bracket is minus omega squared minus I gamma omega plus omega naught squared and then plus this. Okay. Then after this, you name these two terms as delta. Okay, these two terms is delta. You name it as delta. So you have this. So this is exactly the same as the articles. All right. So if I if I manage to get these results, means that my approach is correct according to the papers. So here is to rearrange. This one I put on the left hand side, and then this one I put on the right hand side. It's nothing new. I just want to rearrange left to right, so they are the same. Means that I want to use it for my further calculation. Okay, and then after this, there's not the end of the story. Okay, we need to combine this with wave equation that we have derived just now. This yellow wave equation, we need to combine with the these results. We need to combine this with these results from the material itself. This is the response of the material. Okay. So in order to do so, okay, then we need to do something. We take the wave equation, the yellow one just now. Okay. And if you look at the results from the paper, and this is for the medium, you have E squared over ME. But this wave equation, this part you have only E here, right? So we want to make it whichever multiply with E carry the E squared over N. So we copy paste the wave equation just now that we just derived. You multiply with this. Okay, I think I make it green so that you can see this. We multiply every term like this, left and right of the equation. You can do this multiplication because of it is an equation. There's an equal sign here. You do the same thing on the left and on the right of the equation. So you do not change anything. You just change the appearance. Okay, so when we multiply, then we have this. Okay, and then here, according to the paper, the time dependence part of E is like this. So you take the double time derivative. Okay, you take this double time derivative, then you get the minus omega square and the time derivative. Okay, and after this, you okay, the del square operate on E. You don't have any time here, any resultants of omega here. This also, this del square P over del T square, the P carry this. So if you take the double time derivative, you have the minus omega square. So if you substitute your E like this into here and into here, you have this time factor. If you substitute this P into here, you also get the time factor exponent. So that's why you delete all the exponent and retain the minus omega square. So you have this result. So is this step okay for you? Is it okay? So I try to go through slowly. You can capture the consideration. Okay, so this is from the wave equation. Okay, so after I play with the wave equation, I take all the time derivative because I don't want to see time derivative inside the wave equation. Okay, so I use the same consideration that we derive this equation as in the articles. In the articles also don't have any time derivative anymore. It already taken the time derivative. So that's why you have this omega square, something like that. So after this, here I managed to make it the same as this. This is the wave equation that you already taken care of the time derivative, and the highlight green here, this term and this term, exactly the same as the results from the paper. So that's why my purpose to rearrange these results of the paper is like this. Okay, this go to the left and then this go to the right. So this term, this green term equals to this whole thing. So whenever I see this equation 2, the green term I replace with this. So this is what I replace. So this is the green terms. And the green terms of it here. Okay. But okay, so the green term, is it come from the paper? Correct? So the green term I replace with this longer terms.